So, some Venn diagrams to deal with here. We've got a literacy and numeracy test, and then people taking it. So, in this Venn diagram, if I call this L, this circle here is going to be the percentage, the section of people passing the literacy test, and this circle here is going to be the section of people passing the numeracy test. So, in the middle, they're going to be passing both. And outside the circles, they're not going to be passing either of them. However, we are told that everyone who took the skills test passed in at least one section. So I can put 0% outside. Okay, how to get the inside bit? Well, I can't put 88% here because the 88% is actually everyone here. So what can I do? And the same with the 76%. Well, actually, I can use that fact because if this is 88%, then it must be that this is 12% because it's got to add up to 100% in total. So I've basically done 100 minus 88 to get that bit there. And I can do the same with the 76%. So 76% passed the numeracy section. That means all of this is 76. So I can do 100 minus 76, and that's going to be 24%. Okay, I'm not going to write down my working for that. And then what next? Okay, so the middle bit must add to give all of this must add to give 76. So I can figure that out now. It's got to be 64%. And I can also see that that will then add to 88%, and all is good. Now, another way you could do this question would be to call this A, B, C and set up equations to solve it. But actually, I think kind of covering things up and thinking what's missing is a better approach. Right, on to the next bit. Not just one, but two conditional probability questions where we're given an extra condition. Okay, let's go with it. So, one person's chosen at random. Work out the probability that they passed the numeracy section given that they passed the literacy section. Okay, so for part one, because we know that they passed the literacy section, we can ignore all of these people. They're gone. This extra condition gets rid of them. So what's the probability they passed the numeracy? Well, there's 64, and it's going to be divided by 88. So basically, I ignore the 12%. It's then just the number of people passing numeracy divided by the total number of people in total people that I have. Of course, in this case, it's a percentage, but that doesn't actually matter. You could treat this as having 100 people, and then you can see that 100 people in total. And then when I say that they passed the literacy section, we ignore these 12 people here. And so I've got 64 that passed numeracy. I've got 88 in total, so that's why it's 64 over 88. It doesn't. What I'm trying to say is it doesn't matter that they're percentages. It still works in the same kind of way. Okay, you could cancel that down, but actually it's fine to leave it like this and non-cancelled for a probability. And then the probability that they passed the literacy section, given that they passed only one section. Okay, so now I know they only passed one section, they didn't pass both, I can get rid of these people. So what's the probability they passed the literacy section? Well, there's 24% that did, and then in total, there were 36%, and that's going to be my answer for the second part. Just be careful with these conditional probability questions, just cancel out the people that you're not interested in, and then it's like a typical probability question in a Venn diagram.